Before we start, please subscribe to this channel. My name is Daniel and let's see what we have today. So in this video, I am taking Bernoulli's equation example number 1. I have already done an introduction to this one. You need to look at that. It will help you to get the concept how to change a Bernoulli's equation into a linear first order differential equation and then using the integrating factor to solve. Now the Bernoulli's equation and the linear first order differential equation are very similar. The only difference is that for Bernoulli's equation, the function on the right hand side from what we have here has a variable y to an exponent that is greater than 1. As you can see, we have y to exponent what? 4. So go look at that video, intro to Bernoulli's equation, come back and start with this one. Now we have 2y minus 3 dy dx equal to y to power 4 e3x, exponential function to 3x. This is a Bernoulli's equation, so how do we solve it? We need to first reduce it into a linear first order differential equation. Then we will use the integrating factor to solve. So like I said in the introduction, the first step of a Bernoulli's equation is to get rid of y to the exponent n, which is y to power 4, that you have on the right hand side of the equation. We need to divide the whole function through by y to power 4 so that we can cancel this side. But before we will divide, let's rewrite the equation because we need to rewrite the equation in this form. So first, this is the form of Bernoulli's equation, dy dx plus the function p in terms of a variable x, y equal to q y to power n. So that is what we are seeing here. The function q is this one. So the function p is mixed. So now we need to rearrange the equation in this form. So to arrange that, this is a negative function. So we need to make the dy dx a positive function. So what we will do is that let's carry this side of the equation to the left side and this side to the right side. So we have minus y for e3x equal to, let's cross this one. We have minus 2y plus 3 dy dx. So now I can rearrange the equation correctly. Let me carry this to this, write this here and write that one there. So we have 3 dy dx minus 2y equal to minus y to power 4 e3x. Okay, so now we want to leave it such that dy dx here will stand alone. So I can divide through by 3, divide this side by 3, and divide this side by 3. So this will take care of this. We are having dy dx minus 2 over 3y equal to minus y to power 4 times e3x over 3. I will be getting rid of this y to power 4, so that is why I didn't underline it. Alright, now this equation we have here is in this form, as you can see. So we have our dy dx, we have our p function, which is minus 2 over 3. Then we have y, which is here. Then we have q, which is this over this. And then we have y to power n, which is what? Here. Now, so this is how the form will be. After you have been able to rearrange the equation, now you can divide both sides by what? Y to power 4, so that we can get rid of this side. Now, when I divide both sides by y to power 4, the result is giving me y negative 4 dy dx minus 2 over 3 times y to power minus 4 equal to minus y to power 4 dividing y to power 4. This will take care of this, e3x over 3. Now, how did I get this? When we rewrite this one, we are having y to minus 4 dy dx minus 2 over 3 y to minus 3, because I have a y here. This and this are the same. I'll take the base, I add the powers, equal to e3x out of 3. And let's label this one equation 1. How did I get this? So to those of you who are still confused, let's go back to what we had here. This is the same function. So now I was supposed to divide through by y to power 4. So this is the same as dy dx over y to power 4 minus 2 over 3y over y to power 4 equal to minus y to power 4. We divide by power 4 e3x over 3. Now, note that this will take care of this. This is division, so I can just reciprocate the function here. So I'm having dy dx divided by y to power 4 minus 2 over 3y divided by y to power 4 equal to e3x over 3. Then when I reciprocate, I'm getting dy dx times 1 over y to power 4 minus 2 over 3 times y times 1 over y to power 4 equal to e3x over 3. I want to make this side a linear function. So when I make it a linear function, 1 over y to power 4 is the same as y to negative 4. So I have dy dx times y minus 4 minus 2 over 3 y times y minus 4 equal to e3x over 3. Now note that from indices, this side is power 1. So you take one base, you add the powers. So you're having y minus 4 dy dx minus 2 over 3 y into 1 plus minus 4, giving you e3x over 3. This side is going to give you y minus 3. So that was how we got this. Let's move on. I guess you got it now. Now, from the introduction, we learned that when you get to equation 1, consider the left-hand side of the equation and consider the variable y. Now, we have here y to exponent minus 3. Substitute this to be equal to z. So here you say that let z be equal to what? Y to power minus 3. Let's label this equation 2. Now, your next step is differentiate the z with respect to x and differentiate the function y with respect to x. Listen very carefully. So when I differentiate z, I am having dz dx equal to, now let me differentiate y with respect to x. When I differentiate y, this is exponent minus 3. Use it to multiply the function. Minus 3y. Now, raised to the power minus 3 minus 1. Reduce the power by 1. When I subtract 1 from minus 3, the result is minus 4. So y minus 4 dy dx. Let's label this one equation 3. Now, in the next step, consider the exponent negative 3 alone, or this one, the value negative 3 here. Use it to multiply equation 1. This is because we need to reduce this equation 1 into a linear first order differential equation. So anytime you get here, just consider equation 1 and look through the function very well and multiply it by what? The value that you have in front of this function, equation 3. If you continue to do this, you need to know that you need negative 3 to multiply to make this equation the same as equation 2 and 3. Now watch very carefully. Multiply equation 1 by negative 3. So let's do that. This is equation 1. So we have minus 3 y to minus 4 dy dx minus 2 y to minus 3. This is over 3 times minus 3 equal to minus e 3x all over 3 times minus 3. So this side is supposed to be minus e because when we cancel we have a negative sign here. So that is what I have there. Let me rewrite this function and let's continue. From here, this 3 can cancel this one. This one can also cancel this one. So we are having negative 3 y minus 4 dy dx. Now watch very carefully. This is multiplication. We have negative here. So this will be plus 2y minus 3 equal to, this negative will cancel this one. So we have e3x. Let's label this one equation 4. Now you can see that the left hand side of the equation 4 has both equation 2 and equation 3. Now watch, this side of the equation, minus 3y to power 4 dy dx, this side of the equation is the same as this, minus 3y to power 4 dy dx. And this is equal to dz dx. Again, this side of the equation, y to power minus 3, is the same as equation 2. And this is equal to what? Z. because z is equal to what? Y to power 3. So now we can substitute equation 2 and equation 3 into equation 4. So we have dz dx plus 2. We have 2 here. This side is z plus 2z equal to e3x. We can label this one equation star. Now when you look at this very carefully, this is now a first order linear differential equation in terms of the variable z, and it can be solved with the help of the integrating factor. Now that we have gotten here, we haven't finished. We now need to use the integrating factor to solve this side of the equation. Now, we compare equation star with a linear first order differential equation in the form dy dx py equal to q. Q here is a function, which is this, and P here is the value 2. Now, note very carefully, I was supposed to use the variable Z, not Y, but it's still the same, so we can compare. Let me put Z here, but this does not change anything. Okay, now dz dx is the same as what we have here. So, Z here is the same as Z here. So, we can say that P equal to what? 2, and Q equal to what? This side. So we have Q equal to e to power 3x. In your next step, find the integrating factor. Now we learned that the integrating factor is e integral of what? P dx. Now look at my videos for linear first order differential equation. This is what we are doing. So like I said, you need to reduce a Bernoulli's equation into a linear first order differential equation before you can use the integrating factor to solve. So I have already done linear first order. All these examples are there, so you can look at those videos in this same playlist. The integrating factor IF equal to E integral of P dx. To find it, we substitute the function P. We were so lucky that the function P is just number 2. So now we put it here. IF equals E integral 2 dx. Now this that you are seeing is the same as E integral of 2x0 dx. So that when I integrate, you will not get confused. So now integral of 2x to exponent 0, note that x to exponent 0 is the same as 1. 1 times 2 is the same as 2. So when I put it in this form, it will be easy for some of you to understand. So now integrating this, the result is giving us 2x0 plus 1, add 1 to the exponent divided by 0 plus 1. Now this is the same as 2x to power 1 all over 1, giving us 2x. So the integral of the value 2 is what? 2x plus c. Now I'm not interested in the constant. So the integrating factor IF is equal to what? E to the power what? 2x. So now after finding the integrating factor, which is what we have here, use it to multiply equation star. Now this is our equation star. Let's multiply by IF. So we are having dz dx times e to the power 2x plus 2z times e to the power 2x equal to e to the power 3x times e to the power 2x. And we can work on this side. E2x times z equal to e to the power 5x. The bases are the same, add the exponent. From the linear first order differential equation, which I've already discussed, when we get to this part of the equation, we need to consider the left hand side of the equation and take the derivative of the variable z and the integrating factor. This is because the derivative of e to power 2x and the variable z will give us the left hand side of the equation. This is the principle of linear first order differential equation, because this is now a linear first order differential equation. So now you take derivative of this and this. Remember the derivative of the integrating factor and the variable you have here. So this is d dx, derivative in terms of x, of e2x times z equal to the right hand side of the equation, e5x. Your next step is to integrate both sides of the equation. We have integral of d dx e2x z equal to integral of e5x. Now this will take care of this. We are left with e2x dot z equal to integral of e5x. Now we need to integrate the right hand side of the equation. If I have the integral of e raised to the power, let's say ax, then the integral of this function is equal to 1 over a e raised to the power ax. Remember that a is an integer, any positive or negative number. So if I have integral of say e to 2x, then it's the same as 1 over 2 e to the power 2x. If I have integral of e minus 2x, then it's 1 over minus 2 e to minus what? 2x. Do you get that? So now the function is what? E to power 5x. So when we integrate this side, the right hand side, we are having e to 2x times z equal to 1 out of 5 e to what? 5x plus c, the constant of integration. Now go back again, we are not done. In equation 2, we said let z be equal to something. So this is what we have here. You said that z is equal to y to power 3. We must substitute that. So to do that, we just say that but z equal to y minus 3. So when I put that in, I'm having e 2x times y minus 3 equal to 1 out of 5 e raised to the power 5x plus c. The rest is now calculation because we have done integrating both sides of the function. So you just know how to manipulate the function to reduce it to the simplest form. Now from here, we can rewrite this as e 2x all over y to power 3. This is over 1. Okay, so this time this is this times 1 is that. So this is equal to 1 over 5 e raised to the power 5x plus c. Now I can take LCM on the right hand side, then cross multiply and make y cubed the subject. You can choose to leave your answer here. And when I move on, this is giving me e2x all over y to power 3 equal to this times 1 e5x all over 5 plus c. Don't forget this is over 1. LCM is giving me 5. 5 here is 1. 1 times the numerator e5x plus 1 into 5 is 5. 5 times c is 5c. So from here we can have 2, the exponential function of that, y to power 3 equal to e5x plus 5c all out of what? 5. Now you can cross multiply from here. Okay, you don't need to show this thing. So now this times this, so we have 5e2x this time that equal to y to power 3 times e5x plus 5c. Okay, I want to make y cube the subject, so I'll divide through by this. So y to power 3 is equal to this over everything we have here. I'll cancel it, this side over what we have here. So we have 5e2x all out of e to power 5x plus 5c. I think it's okay. I don't need to break this down again. So this is it. You can make y the subject by taking the cube root of that. You are just making the word complex. Let's leave it here. So this is the end of the calculation. All right, so thank you very much for joining me. This is Daniel. Please subscribe to this work. Please share this work. Share this with people around and subscribe to this work. And see you in the next one.